Okay, so test 1B, this is continuation of balancing of equations. So let's start with the number 1. Here 1, okay, let me read the question. Ferrous sulfate decomposes on heating to give ferric oxide, sulfur dioxide and sulfur trioxide. So let us write here a little bit below, giving space above it. Ferrous sulfate decomposes. So let's write the formula by remembering our starter. Ferrous ion Fe2 plus, sulfate ion is SO4, 2 minus here, 2 plus and 2 minus cancel, so 1 is left, which will need not be shifted. Now in every decomposition reaction, there's a big molecule on the left side. There is one big molecule, okay. Decomposition reaction is a reaction in which a big single, okay, I repeat, a big single molecule reactant breaks down into two, okay, at least two or more smaller molecules on the right hand side. It's called a decomposition reaction. So in every decomposition reaction, we'll see only a single big molecule on the right side and at least minimum two products or more than two products. Keep that in your mind. Okay, so decomposes to form, the first product is ferric oxide, I think. Yes, ferric oxide, then plus sulfur dioxide, and then one more product, sulfur trioxide. So in this decomposition reaction, the one single big molecule breaks down into three smaller molecules. Okay, let's remember our starter and write this formula. Ferric ion is Fe3 plus, and then oxide ion is O2 minus, right? So this valency at the top 2 and 3 can't cancel, so 3 at the top of Fe will go to the lower backside of O, and 2 at the top of oxide will go to the lower backside of Fe, and so the formula is Fe2 O3. And from our formula, we know that sulfur dioxide is SO2 and sulfur trioxide is sulfur S. Tri means 3, so sulfur trioxide SO3. Okay, so here this happens when we heat it. Means ferrous sulfate molecule decomposes on heating. Okay. Our next job is to balance. So let us start, as we have been discussing and doing the balancing. We know that the only method for balancing of chemical equation is trial and error. So we can start with the ones that appear first and begin balancing one type of atom after another. There's no hard and fast rule. It's by trial and error, right? So at the back of Fe, no number means 1. So left side is 1 Fe, right side 2. So we can put right in front because we aren't allowed to balance from back side or in between atoms. Right in front. So 2 Fe on the left hand side of the arrow and 2 iron atoms on the right side. So they are balanced, equal on both sides. Now if you put here at the back of S is 1. But there's a number here 2 now right in front. So this 2 main script always belongs to the atoms that follows it. Okay, so 2 ones are 2 sulfur. On the right side is 1 plus 1, 2 sulfur. So balance so far. The next atom is here 2 fours are 8 oxygen atom. Let's count here 3 oxygen atom on the right side plus 2, 5. And 5 plus 3 is 8. So now this equation is balanced. Settle whether they are molecules or atoms. More than one atom is molecule, so 1 iron atom, 1 sulfur atom, so 2 atoms together plus 4 oxygen atom means there's 6 atoms in ferrous sulfate, so it's a molecule. 2 plus 3, 5, so it's a molecule. 1 plus 2, more than 1, 3 molecule. 1 plus 3, 4 atoms make sulfur trioxide. So every compound here, whether it is the reactant on the left or the products on the right, are all molecules. So let us read the balanced equation. 2 molecules of ferrous sulfate on heating decomposes into 1 molecule, no number in front means 1 molecule of ferric oxide, 1 molecule of sulfur dioxide, and 1 molecule of sulfur trioxide. The next one, 2. Calcium carbonate decomposes on strong heating to give calcium oxide and carbon dioxide. So calcium carbonate, the big molecule on the left side, again decomposition. So there will be only one big single molecule on the left side, and the condition is we must heat it strongly. So strong heating or strong heat. Using your starter, calcium ion is Ca2 plus, right, and carbonate ion is CO32 minus. So here the top 2 and 2 cancels, so the formula is CaCO3. It decomposes into, a little bit below the arrow we can write calcium oxide and carbon dioxide. So there's a formula here is Ca2 plus calcium ion, oxide ion O2 minus, so 2 cancels. So that's the formula. Carbon dioxide is CO2, we know that. Okay, so let us balance it now. Ca means calcium atom at the back, no number. So 1 calcium atom on the left, and here also 1 calcium atom on the right. So balance so far. As we have been saying for a while now, that Ca represents calcium atom, C represents carbon atom. They are not same, right? So 1 carbon atom on the left, and here also 1 carbon atom on the right. This is not carbon, this is calcium. Okay, please note that. 3 oxygen atom on the left side, and here 1 oxygen atom, here 2, so 2 plus 1, 3 oxygen atoms. So this is also another skeletal equation which is already balanced, and there is no need to balance it further, right? So the balanced equation will read 1 molecule of calcium carbonate on strong heating decomposes into 1 molecule of calcium oxide, 1 molecule of carbon dioxide. Let's go to the third one. Lead nitrate decomposes on heating to give lead oxide, nitrogen dioxide and oxygen. So lead nitrate, Nitrate. So lead ion is Pb2 plus, nitrate ion is NO3, 1 minus, here 1 valency, here 2, so can't cancel. So while bringing down this 2 at the top of Pb to the lower backside of NO3, we must put a bracket because nitrate ion clearly is a compound ion. By that we mean this ion contains more than 1 atom. See here, 1 nitrogen atom, 3 oxygen atoms, so 4 atoms make this nitrate ion. So an ion containing more than 1 atom is a compound ion, and while we bring a valency greater than 1, which is 2 in this case, then the compound ion has to be covered or closed up with a bracket before we do that. So on heating, again I think yes, changes into or decomposes into lead oxide, nitrogen dioxide, nitrogen dioxide, and oxygen. The question says that. So looking at the question paper, we get these things. So lead ion is, as we said, Pb2 plus. Oxide ion is O2 minus, so 2 cancels. So this lead oxide formula is PbO. Then nitrogen dioxide, so N is nitrogen, dioxide means di means 2, so O2. Oxygen is O2. We are now very familiar with this, right? Oxygen. Now here, left side Pb1, right side Pb1. Balance so far. Nitrogen is 2 ones are 2 on the left side. Here only 1. So the only way to balance this would be, we'll put here 2 to make it equal to this 2 nitrogen. But before we do that, let us see one more thing. Here I think we need to apply a little bit of a common sense. So let us say, okay, this one is a little bit, we need, if you can remember this, 2 lead nitrate on the left side, 2 molecules. You keep that in your mind. Okay, memorize it sort of, because there is only one reactant. Very easy to, and consider this as already a correct, means we use this now to balance the right side, means this is unchangeable, this is correct, and so this is going to remain 2. Everything here is correct, so 2 lead means here also 2, you do that. Then here 2 2s are 4, right? 4 1s are 4 nitrogen, so here there is no nitrogen here and here. So ahead of the oxygen you balance the nitrogen, because oxygen atom is appearing so much, it's more difficult to balance the ones that appear more frequently or appearing more number of times. Least number of times an atom occurs, that atom you try to balance first. It's always easier to balance that way. So nitrogen occurs only once on the right side, so let us remember to balance nitrogen ahead of oxygen. 2 2s are 4, 4 1s are 4 nitrogen, so the only way to make that 4 here is there 4. So now that's balanced. Now finally go to the one oxygen which appears so many times here, 3 times in fact. So here 2 2s are 4, 4 3s are 12. So 12 oxygen atoms on the left side, 2 1s are 2 oxygen, 4 2s are 8 oxygen, 1 2s are 2, so this is now 12. So when we did that, the balance the nitrogen ahead of oxygen, we found out that the one which is harder to balance oxygen has automatically got balanced by doing the balancing of nitrogen. So we remembered that's easier. So remember, memorize these 2 molecules of lead nitrate. Next, balance the nitrogen ahead of oxygen, and this equation will turn out to be balanced even for oxygen. So that's, as we practice, those things comes to us quickly and easily. Okay, so here let's go to the fourth one. The fourth one is decomposition of water on electrolysis gives hydrogen and oxygen. Water, so you write here water. How do we decompose water? By passing electric current, that is called electrolysis. Then it breaks down into hydrogen. The question paper itself is telling us this. So it's quite easy. So oxygen we know by now is O2, hydrogen is H2. The skeletal equation is ready, so let us try to balance 2 hydrogen atoms on the left side, 2 on the right side. So far balanced. Next, 1 oxygen atom on the left side, but 2 on the right side. So we increase the lower one, 2 1s are 2, to make it 2 oxygen atoms on the left equal to 2 on the right. The moment we do that, the hydrogen got changed. So 2 2s are 4 hydrogen atoms on the left side, but here only 2 on the right side, so we need to put a bigger 2 than this subscript. 2 2s are 4. This equation is balanced. Molecule, as we can see, molecule, more than 1 atom. So at the back we check 2 molecules of water on electrolysis decomposes to give us 2 molecules of hydrogen and 1 molecule of oxygen. And the fifth one, let's see the fifth one. The fifth one is decomposition of, again, 1 to 5 is decomposition reaction. That means from question number 1 to 5, every of this reaction has only 1 big molecule on the left and at least 2 or more molecules on the right, smaller ones. Silver nitrate chloride on exposure to sunlight yields silver and chlorine. So silver chloride, let us write the formula. Silver ion Ag1 plus, chloride ion Cl1 minus. 1 and 1 valency, the formula will remain like that. So when we expose this compound silver chloride to sunlight, it decomposes to silver metal or silver atom and chlorine gas or chlorine. So we know silver means Ag. Ag plus is silver ion, but Ag is silver atom or silver. So when we say silver, we mean silver atom, and chlorine we know is the gas Cl2. So our next job is to balance the skeletal equation. So 1 Ag on the left side, 1 silver atom on the right side. Balance so far. So 1 chlorine atom on the left side, but 2 chlorine atoms on the right. So we balance the lower one to 2. 2 1s are 2 chlorine atom. So now 2 chlorine atom balanced on both sides. But the moment we do that, silver has increased to 2, so we put here 2. So the equation will not read, this is more than one molecule, more than one atom, sorry, at the back 1, so 2 atoms make silver chloride, so molecule, only 1 at the back, so atom, 2 at the back, so molecule. I'll read the equation, 2 molecules of silver chloride on exposure to sunlight decomposes the 2 atoms of silver and 1 molecule of chlorine. Let us complete the decomposition reaction. I think one more is there, so 6. Let us see what is the decomposition. Decomposition of silver bromide 2 on exposure to sunlight gives silver and bromine. So silver bromide, this time it's silver bromide. Silver ion Ag1 plus, bromide ion Br1 minus, so 1 and 1 valency, so it's the formula remains that way, AgBr on exposure to sunlight gives silver and bromine compound, bromine liquid. So here now, silver we know is the atom, Ag, bromine is the liquid, Br2 formula. So very similar to the previous one, Ag1 silver on the left, 1 silver atom on the right, balanced so far. 1 bromine atom, but here 2, so to make it equal to 2, so 2 ones are 2 bromine atoms on the left and 2 on the right now. The moment we do that, silver is increased to 2, so we put here 2. Now the equation is balanced, right? So like this, very similar, 2 molecules of silver bromide on exposure to sunlight decomposes into 2 atoms of silver and 1 molecule of bromine. Okay, we'll continue the next 7 to 10 in the next class.